everybody. Malcolm Sparks, founder of JUXT, and talking about closure on SCIs.
Great, so Babashka-Conf, it's great to be here. It's wonderful to speak at the first Babashka-Conf on the first talk, and it's going to be a really exciting day. So this talk is called Closure on Skis. I don't know how you pronounce ski, or so I know how I pronounce it because it kind of works better. The alternative title is about running Babashka in a database. So that's what I'm going to be talking about today. So a quick context setting. I'll explain where I'm coming from, what the problem statement is, and then we're going to try and go straight on to coding and live demos, and we'll see how that goes. I'm going to try to finish quite quickly. Stefan's going to let me know how much time I've got left, and then we can have some questions, hopefully 5-10 minutes of questions afterwards. So hold on to, if you have any questions, hold on to them till the end of my talk. So where I'm coming from at the early days of JUXT, we like to build our own internal company tools. This was a holiday application that you could write and say you're going on holiday and book some time off. But it had an interesting property, which I think is a bit lost today, that everything that we put in this single database, and it was a datomic database, was visible to all the other apps. And so we had a timekeeping system that you could put your timesheet in, and you could see your holidays so that you wouldn't book, for example, you wouldn't book a holiday on Easter Day, you wouldn't book a holiday on a bank holiday, but also you would see your holidays that you'd booked, so you wouldn't book your time for times that you were on holiday. I was thinking of, we've built a few of these internal apps, and I really wanted to expand the things that we were doing in the database. For example, we have a problem sometimes in JUXT is that we have a new project that starts, and we want to know, well, who have we got available to start next week on this project? And it would be really good to know that somebody's on holiday, because then we know that they're unavailable. So I think that data is relational, and there are relations everywhere in data sets. And I think we've kind of lost that. The reason why the 1980s relational databases are still with us today and so successful is because I think they capture a really important thing, that data is relational. And yet we tend today, it's fashionable to separate databases. There was a book that I read in the 90s called Anti-Patterns, and in that book it was all the things that you shouldn't do in architecture and programming. In that book, there was an anti-pattern called the data silo, and this is where there would be finance and accounts and shipping and all these different departments, and they would all hold on to their own data, and that was called a data silo. But it's fashionable today to put data in different databases, and we might, in a microservices architecture, all have each microservice having its own database, and that's the current wisdom. And if you read Sam Newman's microservices book, if you read the kind of, there are people who have different opinions, but mostly it's encouraged that you have your own database if you write a microservice. But I think if you do that, and this is a personal opinion, we can all have our own views on this, but I don't like this model, I have to say. And I think what's happening here is that you're building walls between your departments, you're building walls inside your database. So we're here in Berlin, and we're Berliners, and we know what to do with walls, don't we? So I'm really interested in this idea of a single database. And in fact, when I looked at this problem, I saw actually there's this idea that you separate things into separate databases. If you look at the macro view of this, I wrote this kind of little diagram a few years ago, and I realized that every single company, including in JUXT, have this huge array of SaaS services that they use, and every SaaS service is a little database. And if you want to ask a question and join across data, if you want to know how many of my MailChimp customers are also my kind of current customers, or how many, you can't. You have to write these scripts. You have to pull the data down, move it, and often it's stale, and it's a big job. So I feel, and it's not also very good for the individual vendors, because if you're the custodians of customer data from another company, then you have a big responsibility. You don't just become an expert in accounts like Sage, you also become an expert in data security, because you have to protect all this data. So I really like this model over on the right, which is where you get to keep your data in a single database. That would be the ideal. We'll leave practical concerns to one or to aside for now. And that all of these expert organizations with their wonderful functionality would come and work on your data, but they wouldn't have the responsibility of looking after it. So I like this idea of a shared state model. There's another problem that I have with microservices, and that is to do with data consistency. So if you remember our example about the holiday system, and we want to know who's on holiday. A new project comes into JUXT and we say who's available. And at the very point that we assign Alice to the project, we find out that Alice decides, oh, I want to go on holiday next week. So Alice books a holiday at exactly the same time as we assign her to a project. And this happens all the time. And this is called a consistency problem. And this causes more and more complexity. I know stories of people who have booked hospital appointments in the UK and they've travelled, not 18 hours, but they've travelled 4 or 5 hours down to London for a specialist appointment and then discovered that the appointment doesn't exist, or it's been double booked, or the consultant that was going to see them is on holiday. And this is a real data consistency, causes complexity, also has a significant impact on people in their lives. So I've got a kind of solution to this. There is a solution to consistency, but the first thing that we do is we put all of our data in a single database, right? We have to do that. And the second thing is that instead of an application reading the data, making a decision and putting the data back, applications, we write these little functions, and the function knows when it arrives at the head of a queue, what to do. So if it's I need to book a holiday, it will be posted as a job, if you'd like to think about it like a function. Or if you've ever used a closure atom or a closure agent, you'll be used to this idea that you write a function and you send it to the atom or agent, and when it's ready, it will get the very latest state of that atom or agent. It will book the holiday, or see that there's no conflicts with anything else. And then by the time the next function comes along, seeing if we can allocate Alice to a project, we'll see, Alice is on holiday, she's not available, so we'll be able to fail. So this is a way of preserving consistency. So this is where I'm coming from. I want to be able to create functions that run in the database. And this is a horrible idea. We had this in the 90s. When I started my career, I was an Oracle Forms programmer, and I had to write in this horrible language called PL/SQL. And it looked a bit like the stuff on the left, Algol. I did a little talk at our 10-year birthday party, and I put this slide in to compare and contrast the difference between, the huge leap in what it's like when you have a very beautiful language like Babashka. So this is what I want to achieve. So yes, there are reasons why code in the database has got a bad history. One, I think, is the syntax and the language, how difficult the language is to test. We know that's not true for Babashka. You can run it anywhere. And another is the problem of just being able to run test suites and the agility. And another one is actually version control. When we have code in code bases, we can have them in Git and we can version, so we can keep track of changes. The problem with code in the database is that you don't know where it came from or who posted it in or when it was there. So it's very nice if you can have a bitemporal database, and there aren't that many around, but I know of a very good one. Now, for writing code in the code base, I did actually, because I knew Babashka existed, and I wanted to write my code in the database. So the answer was obvious. I should write in Forth. So I spent the first about 6 months with this idea, because I was very worried about this code in the database. See, I wanted something that was really, really unlikely to very controllable, very, very small, unlikely to use up much memory, unlikely to do anything bad. I wanted this principle of least surprise and principle of least power. I didn't want a very powerful language. And Babashka, it's way too powerful. I know how powerful Babashka is. So I avoided it. And so we ended up with, I think I've got some examples here. Yeah, this gives you an idea of the sort of code that I was writing. I got this from an old commit. Oh, hang on, I've got to put that. Let's put that up there. I think what we'll do is we'll just talk about site and I can show you some of the old code because we're very, very close to the demo. So let me, here, so the word site is about this idea of having a shared place where you put your functions in, and the point about site is it's one place. So that, for data consistency. That's why it's called site. It's a single place where you get this occurrence or an event, everything happens together. I was really put off distributed transactions when in the noughties. I worked on an EJB server. We were trying to do distributed transactions across different, whole corporate infrastructure. We had these things called object transaction monitors, and I worked on this XA implementation in EJB, which was all about distributed transactions. And the problem was that when I realized quite early on that there are so many edge cases and heuristics and things that go on, and failure modes, it is an incredibly hard thing to do distributed transactions. It's much, much easier to forget about distribution and to go back to a single place, and certainly for somebody like me. So I'm going to explain how site works in a single slide. Everything in site works exactly like this, and I'm quite pleased that that's true because I don't have to have lots of other slides. So the first thing is that there is an application that calls a web resource. Now, I've chosen to make everything accessible over REST or GraphQL or over HTTP because I think that that is the modern way that we access services. It doesn't have to be like that, but there's a reason so the HTTP handling is done for you, and the resource isn't a function on a router, or you're not writing a reatit or bidi map. You literally look it up in a database. These resources sit in the database, and their IDs are the URI. So all that the router has to do is look a thing up in the database, says, right, okay, that's the resource. Then there's an operation. This step here contains the Babashka code, and every single method on every single resource is forced to go through an operation lookup. And at the time, when it looks up the operation, it runs a series of data log rules to say, is this operation allowed by the subject, by the person making this operation? Is the operation on a particular resource that, are you trying to look at some sort of history or document or something you're not allowed? So all the access control goes into operations. In fact, operations were created for access control before I kind of even thought about putting Babashka in them. Then there's almost like two phases. There's a piece of Babashka here that is done on the single node that is receiving the request. Then the result of that is then returned to the operation, and then the transaction is submitted. Now, when the transaction is submitted, there's a transact piece of Babashka that is running, but that is running on every single node in the database, and that piece of Babashka has to be deterministic. It has to be repeatable. It has to come up with the same result every single time. So the reason there's two phases here is that this phase is allowed to do things like come up with random numbers, it can contact network services, it can do things in preparation and do some validation on the input. It could just run some Mali. So it does everything it can to try and keep this one as short as possible. And this transaction has to be, this is one that is posted into the database. So that's the architecture. And it happens also on GET requests as well. GET requests have a slightly different step, is that not all GET requests will transact into the database. They can. Sometimes you want to say, if anyone reads this very the very sensitive secret or document, I want to log that. But usually it just stops at the prepare phase and accesses the database. The key thing here is that these little transactions get the very latest version of the database, and they can access the database. This prepare actually can't access the database. unless you're in cheat mode. But it can't, because it would only get a slightly stale version of the database. So we don't want to be making decisions on stale data. It's a very, very principled architecture which we're going to look at. This is the old code. I'm going to show you, just bring up a terminal here, and I'm going to make that a lot bigger. So these are the resources that I have in my current database. So I can have a look at one of those. Here's an operation, for example, get access token. But I'm going to clear out this database. I'm going to now this is a piece of Babashka as well. It's running a thing called gum, or a bubble gum, and it allows me to kind of put little CLI menus. So now if I look at my I've got nothing in there. So everything is all very easy to introspect. I might put in so I'm going to do a bootstrap. Now I can see some resources in there. So if we go back to, let's find a browser. We're running out of time, but I wanted to just give you a quick rationale why I found Sci so compelling, so useful for determinism. So I've written a little notebook yesterday to explain this. So the point being that if I had this as my transaction function and I'm running a rand int, you can see, so I'm taking 10 and I'm adding it to a random number between 0 and 10, of course I'm going to get very different numbers. But with Sci, I can actually say, well, if you're using random, I can deny that function, and so I can throw an exception to avoid. So this is a sandboxing. Or I can even mock out with my own random number generator, and now I can get determinism again. Okay, and this really was the example. I was playing around, and this is where my mind was blown that I actually could control Babashka inside a database, and it didn't, and I could protect the database and the data from the programmer. So for me, this was the epiphany. So I wanted to share that with you. So just very quickly, then we'll do something like, I've got a little swagger here. So I want to show you installing an API into the database. So I've got a little system API. You could run this from petstore.swagger.io. This is a separate application, not in the database. It could be anywhere on the internet. It happens to be on my local machine. But it's trying to find this resource. So I'm going to run a little, let's say, install group, okay? And I'm going to find some resources to install. There's one called system API. So we'll do that one. Now if I look at I can see things like who am I? I've got a who am I resource. So this one here is actually we've got the Open API resource in here, Open API. So we have, this is now a resource _site Open API.json. It looks like this. It's a piece of, everything is Eden inside the database. So now when I run this, I can see the whole Swagger document. So this is an example of, so just quickly show how this is achieved. And we'll go to questions. So I'll go to the, we have a REPL here. Let's find our, and when all of your maps and all of your data is in the database and accessible from a REPL, you have this really powerful introspection all the time. You can always work out what went wrong, why things are the way they are. So here I'm looking into a map here, and there'll be there's an entry there called JUXT site methods, and these are the methods that the resource supports. And this gets fed into things like the method not found, a 405. The resource will know which methods because it will introspect the metadata. And so all of the HTTP semantics are all based on this model here. But every single, this is a get, and it means that we're going to be calling this operation here. So let's just have a look at that one. This is a program. I'm going to show it in my source code. So this one is Open API document. This is what it looks like in my source code. This is an Eden file. So because everything is done through access control, this is done through the operation, create operation. This is a get me the API document operation, which I can then protect from using these rules. In this rule, I said like anyone can call this, but I can choose, well, the subject, I might want to say if the subject's called Fred, or if the resource that they're looking for is owned by Fred, and a whole mix of data log rules there. That's not really Babashka, but it just, it's a really nice feature of the system. So here we have real Babashka. So I'm able to do a database query. This is in pulling up some state. I'm able to find the paths. And to do this in PLSQL would be just awful. But because we've got a data document, we can do a for loop, we can reduce over all the paths. And this is what it looks like. This is a transaction function, and it looks very closure-y. There are certain things that we have to, we do at the end. But yeah, essentially that is the system. I have many, many, many operations now that I've created. I have under OAuth, for example, let's take this one, this is a slightly bigger one. Have an implementation, so we have a Mali schema for input all the requests for an OAuth 2 token grant. We support all of the token grants. So here we can say, get the grant type out of the input, and make sure it's one of the grants that we support, otherwise we can throw a 400. This is all the preparation stuff, where we're creating the prepare blocks. And then down here, this is the transact block. And then here we are, the authorization code grant. And at the end of a transaction, what I wanted to show is that we, right down here, you can see, yeah, this is what we have to return at the end of a transaction, a set of effects. So some of them are, I want to put documents into the database. Some of them might be, I want to trigger an email, I want to put some sort of thing in a queue, or I might want to return back some status, some headers. So this is a sort of a set of effects that you return. Transaction function can't do anything apart from return a vector of effects. You know, it is limited. I think that's it for time. So any questions?
Hello. More than a question, I have a comment, or maybe also a question. Have you checked out JIXT? It's a secure language implementation. It's quite old now. You can discuss it later if you're interested in. But
I'd love to discuss it later. No, I don't know about JVM. Yeah.
Just wondering if you could comment on, so you keep all of the function definitions in source control in these Eden files, and that's how you do version control, and maybe how you keep track of what versions are deployed, or if you have to change versions, how that works compared to a normal kind of closure workflow.
Well, idealistically, I would like to move eventually to a system where the database is the source code control, because I'm trying to move away from the compile run cycle. As I think if you saw Strange Loop talk by Jack Rusher last year, this idea that most of the industry thinks, and that we have source code control, we create objects, and we kind of create these runnable programs, and we push them into production. Because the database I'm using is bitemporal and it has a timeline, and because another wonderful thing about Babashka is that you don't compile it, and even when you get stack traces, it doesn't give you a kind of horrible Java stack trace, you just get told exactly where it is. So the source can live in the database. I don't do anything with the source, try to optimize it or compile it, it just gets run as it is. So this makes it amenable to being able to analyze, and you can analyze the source code. So you could run a copy and paste detector on your database. You can query, because it's data as code, you can query it and make all kinds of database queries based on your source code. So I like the idea that eventually I will just become so confident and dependent on the system that I will use the production database as the code base as well. I know that that is also something that ruffles a few feathers. People think, no, code goes in a code base, data goes into a database. Don't mix, don't cross the streams, and you know, everything will be fine. Yeah, so I've got this kind of like story to tell about, you know, developers having their lovely world of the code base, and they do their continuous integration, and they reach the the new version into production. But that's the first time that that version of production meets production data. These people on the right have to live with 5-year-old production data that's smelly and awful. And so the point is, it's interesting actually, these are in kind of, there is a wall between these two communities. And this community on the west is cut off from the community on only that they chuck over their code, their new versions, every 5 minutes if you're a good agilist and you're doing continuous integration and shipping to production every 10,000 times a day. The code that you produce, its first impact, the first time that I've arrived into production, the first time it sees production data is in production. And I think that's an approach we're used to. I don't think this is the only model of doing software development, and I think it is actually better for developers and testers and QAs and production to all work in the same environment. This is kind of really out of scope for the talk, right? But it does answer the question about eventually I'd like to just be a user of the system with certain developer privileges. That would be more ideal for me. Yeah, so it's a good question.
Yeah, thank you for the talk. I'm very happy to see this. One thing I wondered about, so you can control with the sandboxing feature of SCI who executes what, but not how long things will take. So users can still write an infinite loop, for example. How do you deal with that in this system?
Yeah, operations are things that I feel that still would be written by trusted developers. So we're not trying to protect the system from malicious, even though the ability to create an option is something that is subject to access control. This talk is about closure on SCIs. I think it would be quite an interesting principal development model to be able to just create operations like refund customer, create account, and you write them as operations, and you make this language, this set, a sea of operations available to your protocol designers who can design your APIs. So I'm not trying to protect operations from malicious users. However, I would be interested in any tips you have about being able to run in a sandbox and say you've only got this much resources. In fact, that was one of the motivations for Forth, that I would be able to control exactly how many operations were allowed. Or you've run out of 100 credits, you then get terminated. So that is interesting.
So you say that transactions should return effects, and that sounds a little bit like reframe, when you have co-effects and get your side effects before that, and then you get as pure as you can get of a function that you send to the actual store. Yeah. I was wondering if, for example, some of the things that you gather in that particular phase would need to be re-executed if your transaction cannot commit and you have to retry. Is there any mechanism for retry and then fetch it back again, or you have to do that manually? Yeah,
it's a good question. In an atom, you'll have retries because when the functions are run in parallel, and when a function then tries to commit its state, it then checks to see if the state is the same state that it worked with. So it does have a retry mechanism. We don't have a retry mechanism. We don't need to, because we just have a single-threaded queue. So there's no retry needed. It's not optimistic. It's a kind of locking mechanism. So all of the operations are queued up. But it is heavily influenced by reframe. If you've written a reframe app, and partly my confidence that this model works is because I've seen some very complex reframe applications that have worked off a single state model and a very kind of a similar design. So I'm confident that this will I'm just trying to take that model which are very, very large architectures have been built in browsers, and take that to the back end. Yeah, it's a good question.
Hey, nice talk, thanks. So I was wondering how your developer experience is writing basically SCI code in Eden files. So I'm imagining the IDE doesn't understand that very well. And do you have a REPL internet, or is that you're writing it, running it, and compiling, kind of compiling?
Yeah, I'm always running. When I'm changing an operation, in my tests, every test that I run will start up the database in memory. It will load in all the operations, all the things that it needs through. It will say, these are the groups. You saw me install a group. It will say, these are the groups, and then it will run tests. So more often than not, I'm running tests. and then I'm changing the operation in the code. I'm not even compiling it or evaling it. I don't have to worry about that. I just make a change because my test will then load it all in again. So the development experience isn't bad. And Emacs, I don't notice with Cider, I don't notice a kind of any like problems with the editor. I haven't tried it in other editors, but you know, you could say this is an even file. It has an include or something to a closure file, so that could be worked in. Yeah.
Still have a little bit of time.
I'm George Thorpe, thanks very much. I'm all over this. I started my full-time career as a programmer on the IBM AS400, programming RPG, and it was all about having the data centrally and having satellites of code that would access that data. One feature of that system was very much that the schema was front and centre of the data was there. Do you think actually all hell can break loose if we keep the data centrally, but actually we don't have some sort of defined schema to allow people to relate that data? I mean, I know we can run sort of schemaless databases centrally, but if we're promoting it so heavily, is there a danger and is there a way of preventing that?
Yeah, that is a whole other talk that I have, but we don't get. But very quickly, XTDB is a schemaless database. It's schemaless because all hell breaks loose if you try to build schema in a bitemporal database. So in XTDB, schema is evolutionary. And I think it's more like schema on read. We just put our data in maps, and then we discover patterns, and then we start doing, building in some Mali schema and doing some validation. And then schema is absolutely necessary for contracts. I put APIs in the idea of schema, but the API isn't fixed. The API evolves, and the API is the contract with the code. So schemas are sort of the lens. They're the glue really that allows code and data to talk to each other. You know, if you ever do a.b calling .b field on a class, that's the code and form are sort of jewels of each other. So yeah, it is interesting, but I think this is novel because the schema evolves, and you start off with no schema. So time will tell how what the issues are with that approach. But yeah.
And that wraps it up.
Very good. Thank you very much. Thank you.